Hello, Assalamualaikum. My name is Narafika binti Azari. The topic that I would like to present today is about the methods of non-destructive testing that are often used in the ship repair process. There are four methods that commonly used, which are dye penetrant testing, magnetic particle testing, radiographic testing, and also ultrasonic testing. The first method that I would like to present to you guys is about the dye penetrant testing, DPT. So DPT method are used to detect any surface connected discontinuities such as cracks from fatigue, quenching and grinding, as well as fractures, porosity, incomplete fusion and flaws in joints. The principle of this DPT are based upon capillary action where low surface tension fluid penetrates into clean and dry surface breaking discontinuities. Penetrant may be applied to the test component by dipping, spraying, or brushing. After adequate penetration time has been allowed, the excess penetrant is removed. A developer is applied. The developer helps to draw penetrant out of the floor where an invisible indication becomes visible to the inspector. The inspection is performed under ultraviolet or white light depending on the type of dye used, fluorescent or non-fluorescent, which is visible. The working procedure for this method has 5 steps, which are pre-cleaning, application of penetrant, excess penetrant removal, application of developer, inspection, also post-cleaning. The advantage of this method is high sensitivity, which small discontinuities can be detected, few material limitation, rapid inspection of large areas and volumes. The disadvantages for this method are only surface breaking defects can be detected. Pre-cleaning is critical since contaminants can mask defects. Metals smearing from machining, grinding or grit must be removed. The application of this method in the ship repair process is to detect surface defects such as fatigue cracks in crankshaft or screw shaft. The part to be tested is thoroughly clean and a dry penetrant is sprayed on the clean area. If any surface defect is present, capillary attraction draws that dye into the cracks. Second method in NDT is magnetic particle testing, MPT. This method used to detect surface and slightly subsurface flaws in most ferromagnetic materials. The principle for this method are when the workpiece to be inspected is magnetized, magnetic flux is induced. If there is a flaw on the surface, magnetic flux leaks into the air at the position of the flaw. Then magnetic particles, dye or fluorescent encapsulates, are applied to the surface. Those magnetic particles will migrate to the floor, where the magnetic flux leaks and form a flaw indication that is several tenths of time of actual width. The inspector visually identifies the flaw. The procedure to work this method has 4 steps. First, induce, which we induce a magnetic field in the specimen. Apply, where we apply the magnetic particles to the specimen surface. Searching is where we view the surface and look for the particle grouping that are caused by defects. And lastly, demagnetize. Demagnetize and clean the specimen. The advantage for the MPT can find both surface and near subsurface defects. Some inspection formats are extremely portable and low cost. Rapid inspection with immediate results, while the disadvantage is the specimen must be ferromagnetic, paint thicker than about 0.05 inches must be removed before inspection. Post-cleaning and post-demagnetization is often necessary. The application of magnetic particle testing in ship repair is to use for detecting defects and near surface defects in material that can be magnetized. When a magnetic field is induced in the part to be tested, defects allow flux leakage to occur. This causes the magnetic particles used in the test to congregate at the leakage, indicating the location of the defects. The third method that I would like to show you guys is the radiographic testing. It is a non-destructive testing NDT method that examines the volume of a specimen. Radiographic X-ray use X-ray and gamma rays to produce a radiograph of a specimen, showing any changes in thickness, defects, internal and external, and assembly details to ensure optimum quality in your operation. The principles of radiographic testing (RT). In radiographic testing, the part to be inspected is placed between the radiation sources and a piece of radiation-sensitive film. The radiation that passes through the part will expose the film and forms a shadow graph of the part. This variation in the image darkness can be used to determine thickness or composition of material and will also reveal the presence of any flaws or discontinuities inside the material. The advantage of the RT is it has a very few material limitations. Detection of internal defects for thick materials, such as pipelines. Minimal or no part preparation is required. One of the major advantages of RT is its documentation capability. RT provides image of the object under inspection. The disadvantage for the RT is the impact of radiation to health and environment can be considered as one of the major disadvantages of radiographic testing, since a few seconds of being exposed of the radiation can result in severe injuries. High degree of skill and experience is required for exposure and interpretation. Toward this radiographic testing, we have 6 steps. So step 1, surface preparation. Surface irregularities must be removed so that they cannot mask or confuse the image as defects. Second, selecting the right radiation source and radiographic film. Depending on radiographic sensitivity and material thickness, radiation sources, X-ray or gamma ray, must be decided. Step 3, selection of penetrometer. Step 4, radiographic testing technique. Step 5, defect inspection and removal. Step 6, recording. So, the application in ship repair for radiographic testing is radiography is usually confined to the testing of welds in pressure vessels such as starting air reservoirs. Large reservoirs for high pressure use may require only spot tests to be taken. X-ray or gamma ray are used to expose the emulsion of the radiographic film. Welding defect to give a greater exposure of the film, show as darker areas. This method of NDT is ultrasonic testing. This is a method of characterizing the thickness or internal structure of a test piece through the use of high-frequency sound waves. Methods of UT, we have 2. First is reflection. The transducer performs both the sending and the receiving of the pulse wave as the sound is reflected back to the device. Reflected ultrasound comes from an interface, such as the back wall of the object or from an imperfection within the object. The diagnostic machine displays this result in a form of a signal with an amplitude representing the intensity of the reflection and the distance representing the arrival time of the reflection. Second method in UT is attenuation. A transmitter sends ultrasound through one surface and a separate receiver detects the amount that has received it on another surface after traveling through the medium. Imperfection or other condition in the space between the transmitter and receiver reduce the amount of sound transmit, thus revealing their presence. The advantage for the UT is it is sensitive to both surface and subsurface discontinuities. The depth of penetration for flaw detection of measurement is superior to other NDT methods. Only single-site access is needed when the pulse echo technique is used. The disadvantage of this UT method is surface must be accessible to transmit ultrasound. Skill and training is more extensive than with some other methods. Materials that are rough, irregular in shape, very small, exceptionally thin, or not homogeneous are difficult to inspect. The application of UT in ship repair process. Ultrasonic testing is one of the non-destructive tests performed by equipment that transmit high-frequency vibration through the material to be tested. The vibrations are reflected back from the opposite surface or from any discontinuity in the material. Ultrasonic methods can be used to measure the thickness of material or to detect internal or surface defects in welds, casting, or forging, either during manufacture or when in service. Defects are shown as extra pulse to the transmitted and reflect pulses on a cathode ray oscilloscope. That's all from me. Thank you for hearing.